So what we have now is problem 411. In problem 411, we do something that reminds really quite a lot of what we do uh, in the proof for finding the convolution formula in the book. So what do we have here? What we have is x1, which is exponentially distributed with parameter 1. And then we have x2, which is exponentially distributed with parameter theta. And we assume that x1 and x2 are independent. Now, what we do afterwards is we say, well, let y be defined as x1 divided by x2. Find the distribution of y. So what we do in the convolution formula is we define y as the sum of x1 and x2 and want to find the distribution of y. So really nothing new under the sun here, which is also why we're going to do this exercise by just following what they do in the book with the convolution formula. So what we have is, well, we can try to follow what happens in the book actually. If I can find it. Oh, this is very nice. Okay, so what we have is this. We have the probability that y is less than equal to y for some positive y. And we're only interested in the positive y here because x and both x's are exponentially distributed. So this thing is, by definition, the probability that x1 over x2 is smaller than equal to some y. And that is equal to the probability that x1 is smaller than equal to x2 multiplied by y for all the different values that x2 can take. And how do we express that when x2 is a continuous random variable? Well, we do that by saying, given that x2 is equal to some value x, and then we multiply by the density of x2. And we take that and integrate from minus infinity to infinity. Now, what do we have here? Well, we have the integral from minus infinity to infinity of the probability that x1 is smaller than equal to x2 multiplied by y, given that x2 is equal to x. So I've just written the above down again. And let us just look at it and think about it really well, because what does this mean? Well, essentially what we have is that we condition that x2 is equal to x, right? And that means that we can just take this value, and since x1 and x2 are independent of each other, we can just plug it in here. And after we've plugged it in here, then we can see, well, x1 and x2 are independent, so we can just remove the conditions. So here we have probability that x1 is smaller than equal to x multiplied by y multiplied by the density of x2. And what we now have is essentially, well, we can see pretty clearly that this is the distribution function of x1 evaluated in x multiplied by y, and then we have the density of x2 evaluated in x.